LLMs have actually been very useful for extracting information, whereas NLP was expensive in the past. So that parsing of text and being able to say that you have certain things that are coming up is a lot easier than it was ever before. I took a federal court case from the Supreme Court and I wrote a prompt to extract the name of the parties. What was the role of the parties in the case? The prompt was pretty straightforward and I was getting high accuracy. So now you have this mechanism where you can find these relationships where before trying to find the data to train a relationship extraction model was really expensive.
Welcome to the SVIC Podcast, where we deliver tech insights without the hype. Join my co-host Joe Ternasky and me, Jordan Thibodeau, as we break down the latest in tech, cut through the hype, and host top industry guests for exclusive insights. Gradient Descent into Madness. He said, hey, you should have Quentin on here. He's fantastic. Gradient, who has a great Twitter. You all should follow. He writes really funny AI-related Twitter posts and comments. This was a Reddit post from ChatGPT. It says, my little sister uses ChatGPT for homework. It's heartbreaking. And then Gradient says, bullish on NVIDIA, bearish on humanity. Quentin's joining us. He works at a company called Expert AI. And so we're going to be excited to have him here to talk to us about that. Plus knowledge graph stuff he knows about. So thank you for joining us. And then we really appreciate you making time. Maybe you can talk about a little bit about your work with your PhD and then your current work working with Expert AI. We'd love to hear some about that.
Yeah, so my PhD was really about ontologies. And just before I got problems, you asked what an ontology was or trying to bring it down to a lower level. Well, if you take a database tends to have a schema, and then you have the different tables that hold in the rows the data. There are different sort and academic sort around what an ontology is, but as part of my research, it was really about that schema representation. And the schema representation in a way that would not only enable the data to be understood by people by, kind of looking at the representation, but also being able to understand it by computers. So it's really understanding the relationship between the different things. So if we look at a tree here, we have a podcast, that's one entity, and we have three people, that's three other entity types. The fact that a person participated in a podcast, that would be part of the ontology. The fact that you have SVIC Podcast as being one thing, which is a podcast, would be like the data that would be represented by that entity of podcast. And then you, Jordan, Joseph, and I would be three people or instance of a person that would then be considered as being the data. So really, the ontology is that kind of a information representation that enables us to navigate after that, the connection between the nodes. So in your case of both you, Jordan, and Joseph, you not only have that you participate to the podcast, but you also know each other. So that's an additional, or work together. That's an additional relationship that we can put between the two of you. And we would not define that just at your level, but we would define it in the ontology or in the schema by saying people work with people.
Fantastic. Great breakdown.
In terms of my work, Cleon was one aspect of it. And it was really about looking at, well, how can we validate these constructs? And a lot of work was done in the early 2000s in the web ontology language around description logic, but not a lot around linguistic or leveraging linguistic to enable that validation. And this was something that we thought was a problem. And having applied ontologies for 15 years in the industry, I've realized as it is a problem, is that people are using different terms to mean the same thing. So for a long period of time, I worked in the legal domain, and we were representing ontologies for storing documents. And some of it were court cases. And we'd started our model in Europe. So there you have like the notion of jurisprudence, which doesn't really exist in the US, or, it's there, but it's slightly different. And over here, when we try like to bring that ontology, everyone used the term court cases or case decision. And trying like to make them understand that it was the same thing was a problem. So the idea of Cleon, OntoClean, was to really like trying like to bring all of these together and looking at it from the perspective where if I know that something is known in WordNet and has got synonym associated with it in WordNet, I can now say that the two things are the same because people have used actually synonyms to refer to the same entity. As part of my PhD, we then took that a step further of trying like to do set theory. So not only using the linguistic information, but also the structure of the ontology, which is kind of hierarchical. So if you had a class and you had a different set of parents, then you would use a combination of that structure and the linguistic to try to determine whether or not two things would be the same. In practice, there is not a lot of usage of these type of technology for ontology mapping. And most of the reason is, despite the technology having been done around for 25 plus years, a lot of companies are still doing their own proprietary ontologies. So when I worked like at a publisher, we had our own ontology, and we were not really trying like to integrate with external ontology. If we had done that part, it would have been like very useful to have techniques like what I worked on my PhD.
Would that allow them, I guess, I know when doing research on their catalog of books, to find like relationships between certain concepts, or like what are the downstream impacts of good ontology? I hope you're enjoying this video. 50% of our viewers don't subscribe, so if you can hit that subscribe button, and better yet, like also, and if you can, comment, that'd be fantastic. Thanks.
Ultimately, a good ontology is an ontology that is shared by more than one institution, so that you can share that information across multiple systems and multiple organizations. Like, I don't know if you remember, like early 2010s, a lot of the government around the world, especially in the UK or in the US, had this notion of open data on how to publish their own information and data. Problem was that they were all using their own schema. So now you take that information, you try to integrate it in your own system, let's say regulatory management, where you're trying like to keep up to date to the latest regulation. The states provide that information, but it provides it in a format that is not understandable by your own system. So now you need to match the two schema together to be able like to reconcile the information across a system. If there was a standardized ontology that was used by both industry and the public sector, then that would not be necessary, because now that integration becomes seamless. You take the data from one system and you import it in the other. It's very similar to what we have had as problem in data warehousing or around database and trying like to share information across multiple systems.
Gotcha. So then these LLMs come out and say, hey, wait a minute, I can do that for you. You just focus on, I'll do the data scrubbing or finding the relationships for you. So did that open a huge, did that create a renaissance in ontology? Like, what were your thoughts on this when that happened?
Twofold. I think like on the one hand, it really brought a new set of problems. And for many people, the introduction of the LLM kind of like went and say, oh yeah, well, I know we have semantic similarity between terms. But really, when you look at it, and especially if you're using embeddings, the similarities that you're creating for token is really only based on the set of tokens that were used in the original chunk of text. It is contextualized, but it's narrowly contextualized. Whereas if you use an ontology or like another more recent terminology for it or buzzword for it is knowledge graph. Now you can ground it in explicit relationship between node. So let's take an example. You have Acme as a construction company in Illinois and Acme as a bakery in Maryland. They have the same name. If I put like a financial report and I try like to find information and I put that in my RAG, and I look for Acme, if there was no information about construction or bakery in that financial report, how do I differentiate the two? Because they would be seen as being the same entity. Now, if I have a knowledge graph or an ontology that says that I have an organization, Acme, and that organization operates in a particular sector, bakery or construction, now I can ground that into my system. The other big thing that comes with an ontology or with a knowledge graph is that you are providing unique identifier to each entity. LLMs don't understand the difference between Acme and Acme, and even if you were using embedding, it would still not be able to differentiate the two. It may assign a different, slight vectorization difference, but if you were to really try to put additional information about it, you have no grounding that comes in terms of uniqueness, in terms of that kind of aspect. In the semantic web technologies that Tim Berners-Lee kind of put as a thinking principle back in 1999, 2001, that was core to it. If you identify data and you are able to share that data on the web, now you're able to use it in a much better way than what it was before.
Well said. Maybe we can go into your work at Expert AI, because I was looking at the site, and you can talk about how they're using AI and applying it to their different use cases.
Yeah, so Expert AI has been a company that has been around in the NLU, NLP space for 20 plus years. I personally have only joined 6 months ago, or very recently. And my journey to Expert AI, it's kind of interesting because I used to be buying this software and now I am helping selling it and refining it for customers. So it's kind of weird, sometimes to think about coming from buying it and now selling it from that perspective. But really what they've been really good at is combining neuro-symbolic AI. So taking a rule-based system, being able to augment it with natural language processing or machine learning, deep learning, and then create solutions that are tailored for customers. And really trying from the get-go, it was taking unstructured text and translate that into business value. And they have had their own knowledge graph for a long period of time that they have used for entity disambiguation. And I think that neuro-symbolic AI or what we have used on a website to call hybrid AI, it's the right way of thinking about it. Because if you've been a practitioner of data science, which I have for a few years now, you always get to a part where you're training your model to learn patterns. And you get to a point where there is exceptions in these patterns, and especially in a lot of industries, like in the regulatory or legal and regulatory or tax and accounting industries for which I was working, you always have exceptions. And if you're trying to put these exceptions to train statistical models, well, you're not going to learn the right things. You're going to learn exceptions. And then as the more you add exception, the less your model is going to behave in the ways that you expect. That combination of rule-based approach plus machine learning is very useful when you want to achieve not only explainability for transparency, but also when you have to really reach some level of accuracy. The other thing that it can help with, which was a big problem 10 years ago. And again, like I think like up until ChatGPT in November 2022 was the lack of data. The number of times that I was starting a AI project where there was no data available. Well, a rule-based system, albeit expensive to maintain, I will never say the opposite, can get you started because now you are creating rules, you're creating data, and then you include a human in the loop kind of process and feedback loop. So as you get more and more feedback, you're actually getting that data coming back to you. And it's kind of becoming your training data without having to go through an expensive labeling process. Because now you already have a system that you can put in front of customers, which gives you like customer feedback, which is very, very useful to know whether or not you have a product. But also it enables you like to kind of verify that content and augment it over time. With LLM nowadays, like we would have used like synthetic data, or we would have generated synthetic data, and we would have gone directly with a different approach. But I think that combination of machine learning, deep learning, and rule-based system, even with LLMs, will continue like to be the way forward, especially in highly regulated industries or for use cases where the cost to be wrong is very high. So if you think about the healthcare industry, the cost of making a mistreatment could cause someone's death. So you don't want like to get to a point where you are 90% confident that you've made the right choice. You want like to be to a point where you are 100% confident or 99.9, and it's not always feasible because these systems at the end of the day are unpredictable, and LLMs are well-known black box in that way.
Well said. I don't want to hog this whole entire thing here, but Joe, any questions? I know you're a knowledge graph person. That's like your thing, but any thoughts here?
Yeah, I wanted to ask about knowledge graphs, but even before we get there, you described the kinds of use cases in a general way. Are there specific use cases or industries that are really excited about the approach you're describing, or even just feel like this is the approach they have to take because of the cost of mistakes?
I think more and more industries, especially in the highly regulated industries, are going there, or for companies that needs trust. I will take an example, and this is an application where we use this approach. We started the development of this solution. This was with my previous employer back in 2016, so that was early on. And then within a year and a half, we were able to put a product out. Some of the issues were with technology, but there were other aspects. And the idea was to process information from different providers, from state, news agencies, and extract regulatory changes. So being able to identify that the tax rate for particular things was going to change. And then instead of just creating stories, which we would have done in current awareness, saying, oh yeah, be careful, this information, this tax rate is going to increase, decrease. We actually then went and mapped that information to their client database. So now we would only notify accountants that a change was pertaining to some of their client if one of their client in their database had filled information about that particular tax item. And otherwise we would not go through. So I think that was a very good example of having that connection where we were representing the tax forms and the particular items in the tax forms through your knowledge graph, and then linking all of that information to taxonomies, to represent what the tax concepts were, be able to extract that information from the text. And then it came kind of a full circle where you were taking text, which in itself is unstructured and a lot of information, takes a long time to process, all the way to something that was practical, where an accountant could now open their computer, start a client letter and send an email to one of their clients and say, look, you have not used me as an accountant for 6 months, but here, I know you're going to be impacted by this change. And really, I think that you should be taking me back on because now I can do your tax rates and we can do something together.
That's cool. I like that.
It's an interesting kind of cold outreach. But I think the point that I take away from what you're describing is the tax rate changes, the regulatory changes, are coming out in text documents that ordinarily someone would have to read all those documents. And you're saying we could apply an automated system that scans these documents, that understands them to some degree, and that can map them to what our customers have done in the past to see which tax changes apply to which customers and automatically tell us who we should notify. And I could imagine you probably thought to yourself, oh yeah, those customers will also be interested to know if and when they're in compliance with all these crazy tax laws.
Yeah, and I apologize. I think my son just came back from school and just rang the bell when I asked him not to this morning.
All good.
Yeah. So, sorry, I lost what you were. Sorry, I think
I was recapitulating your description. Actually, I'm curious. You described your early work leading up to the PhD, I think, and it sounds like a large part of what you're describing in this new system is parsing unstructured text and building up a knowledge graph based on it. I'm curious, what does that process look like? And then if we have enough time, how is the knowledge graph itself used in many of these question answering systems that are built on language models?
Yeah, I think, having been in the industry and my previous employer, I think I joined there in 2010. And for close to 14 years, I was trying to sell the concept of a knowledge graph. Even though we had that successful application, it was always difficult sell because, to your point, it's very expensive to get started. And the return on investment of a knowledge graph, at least traditionally, would have come 2, 3, 4 years. And it was a very hard sell to say, well, you need to invest to be able to get the return on investment. You don't necessarily know what you're expecting and that type of things. And to go back to something you said earlier, Jordan, or you asked earlier, is the LLM have actually done wonders. Because the knowledge graph is actually addressing a number of limitations that the LLMs have. Like I already mentioned, the entity disambiguation just a minute ago, but also all of them have a cutoff point. They are not up to date with the information that is relevant. And generally, they don't have any information about your own industry or your own process unless it's available online. And even then, their interest is not the same interest as businesses. So the LLMs have been trained on very generic data gathered over the web. Companies are interested either in their own data or very specific data that may not be available online, at least not freely. Like company names, like what the company has got as revenue and all of that information. But at the same time, the LLMs have actually been very useful for extracting these information, whereas NLP was expensive in the past. So that parsing of text and being able to say that you have certain things that are coming up is a lot easier than it was ever before. 18 months ago, I did a demo for in the regulatory space where I took a federal court case from the US, it was from the Supreme Court, and I wrote a prompt, and the prompt was to extract the name of the parties, what was the role of the parties in the case, are they the the respondent or others who were like the lawyers and the law firms, and which law firm was representing which parties. It took me a week to get to a solution. And I would say that the longest time that it took me to do that was actually learning LangChain. It was not really writing the prompt. The prompt was pretty straightforward. And I was getting high accuracy. So now you have this mechanism where you can find these relationship where before trying to find the data to train a relationship extraction model was really expensive. You still have the problem of the disambiguation, which is people is not straightforward. It's a bit easier with companies. Again, the knowledge graph can help there because now for a person, the more information you have about that person, the easier it is to disambiguate.
Right.
If I know that a person was a judge, he sits on the bench in a particular court, even though you have 20,000 Jon Snow that are lawyers or judges, by the combination of knowing his name, knowing which court he sits on, now I can do that disambiguation much faster than just trying to look at it as a string. And people have mentioned with the knowledge graph, it's entities or things, not strings. And I think that that's really core to how they're coming into play now. The second part of your question was really how it does help with question and answering. And it's pretty much the same. Know that you have grounded and you know through the intent, and you have extracted these different pieces of information on the intent of the user. You map that to what you know in your graph about potentially a person. You bring that together, and now you are providing yourself with a much higher accuracy. And you have seen, at least in my space, I've seen a lot of companies that were knowledge graphs, companies that were not necessarily struggling, but they had to do a lot of work to convince what to sell to people. And nowadays, they're just we have business right, left, and center because people realize that this is probably the best approach to resolve some of the issues that LLMs are just surfacing.
Right. Well said. I was in an OpenAI forum, and they were there was two professors from UCLA's med school, and they're using an approach that you're mentioning here with the neuro-symbolic plus the LLMs to get more robust answers to medical questions. Quentin, unfortunately, we've hit our end of the podcast. We want to have you back if you're down to talk about your other aspect of you. There's AGI stuff we want to talk about. There's AI ethics we want to talk about also, regulation and things like that. So thank you so much for joining us for this conversation. We super duper appreciate it. And thank you all for our Patreon supporters. So thank you so much for joining. Joe, thank you. And the audience, thank you all for joining. We'll be back on Monday. Thank you all for watching, and you all have a great day. I'll talk to you all later.